Here first one is again waves subdivisions are there here. First one wave is progressive wave or progressive wave. So progressive wave, another name is traveling wave or traveling wave. This is traveling wave. This is one form of subdivision of a wave, right? And the second form is stationary wave. Stationary wave. Another name of stationary wave is standing wave. So two names are there for these subdivisions, right? So this is second one, this first one. So we'll discuss on these two types of waves, right? So first one is progressive wave, we'll discuss. So what is a progressive wave or traveling wave? So I am writing the definition here. A wave which, right? A wave which travels continuously in the medium. A wave which travels continuously in medium, right? A wave which travels continuously in medium in the same direction, okay, in the same direction without change in amplitude. So this is known as a progressive wave. So wave should travel continuously, right? But continuously medium without in same direction without change in amplitude, right? So if you take a wave like this, suppose this is the wave, this is displacement, this is time. So wave is like this. So already I told maximum distance is displaced, this is amplitude, this is d is not amplitude, this is d1, right? This is d2. So these values d is not equal to d1 is not equal to d2, okay? These values are not equal, okay? Again I will show you. So if you take a wave like this, right? This displacement, this is time. A wave is like this, suppose, like this. Is this wave a progressive wave? No. It is not a progressive wave. What is the definition of progressive wave? A progressive wave definition is a wave which it has to travel continuously. Yes, it is traveling continuously. That is okay. In the medium, so medium, air is the medium here. So in the air, this wave is traveling continuously in the same direction. Yes, it is traveling in this direction only, right? But without change in amplitude. Amplitude is maximum distance of the curve here. This is known as amplitude d. Here this is d1. This is d2. So these values are not equal. Distance. This distance, this one, these values are not equal. So by the definition, it should have same amplitude. Means this distance should be same. Means the wave should be like this. This is time t, right? So your wave should be like this. This is the form of wave, so that this is the displacement d, this is d, this is d, this is d. Followed? So here also, if you see the definition, this correct one. Why? Because a wave is traveling continuously in the medium air. Okay, wave is traveling continuously in the medium, in the same medium without change in the amplitude. So there is no change in the amplitude. This amplitude is not changing here. What is amplitude? This is a mean position, this is a peak position. So the distance from the mean to peak position is amplitude. So without change in amplitude, if the wave is traveling continuously in the medium, in the same direction. So direction is same, continuously it is moving. So this type of wave is known as progressive wave or traveling wave. Progressive wave or traveling wave. Another name is traveling wave. Traveling means why? Because Wave is continuously moving. Continuously means it is traveling. What is the definition? What is the meaning of progressive? It is progressing. Progressing. Wave is progressing. Wave is traveling. So that's why the name is known as progressive or traveling wave. Right? Now you can see the difference here. So already you know what is a transfer wave. Okay. What is transfer wave? What is transfer wave here? Transfer wave is nothing but both are transfer waves only. What is the definition of transfer wave? A transfer wave means the particle should vibrate so that the particle vibration is perpendicular. So this is the direction of propagation. The particles are vibrating, vibrating like this, and the wave is produced, and the particles are vibrating perpendicular to the propagation of wave. It is a transfer wave. Here also particles are vibrating like this, so your wave is produced. So this vibration is perpendicular to this direction of propagation. Because propagation like this, your particle vibrating like this, so this is also transfer wave. Both are transfer waves, right? But both are not progressive waves, right? Both are not progressive, but both are transfer waves. So you can write down like this. All transfer waves, all transfer waves means already we saw all transfer waves are not progressive waves, are not progressive waves. Just we saw no, all transfer waves are not progressive waves. No, first figure you saw. So this is transfer wave, right? Second figure, this is transfer wave. Amplitude is same. This amplitude is same. So this is which one? Progressive wave. This is not a progressive wave, but both are transfer waves. So all transfer waves means this is a transfer wave. This is a transfer wave. Okay. Why transfer wave? Because in this also particles are vibrating, and these particles vibration is perpendicular to the direction of propagation. Here also particles are vibrating and perpendicular direction of propagation. So here both are transfer waves, but these transfer waves are not progressive waves. This is not a progressive wave because this one progressive wave, this D amplitude is not same. Here amplitude is same, but both are transfer, but both are not progressive. That is the statement I wrote here. All transfer waves, this is transfer wave, this transfer wave, but are not progressive waves. But all progressive waves are transfer waves. But all progressive waves are transfer waves. Are transfer waves. Okay. You can see here. This is a transfer wave, but this is also progressive. This is a progressive wave, but also transfer wave. Right? So this is regarding transfer waves. Again, energy will propagate from one point to another point here in this here. Energy is propagating here, and your which one progressive traveling waves, again you can say it is of two forms because all progressive or transfer waves. So your progressive wave or transfer wave, progressive wave or transfer wave or transfer wave may be of two forms, maybe a transfer waves, progressive traveling, not transfer, traveling is traveling. Progressive wave or traveling wave is, first one is, it may be transfer wave form. Okay, already explained. Transfer wave or longitudinal wave also. What is longitudinal wave? So in the previous one I explained about these two waves. When the vibration of this is the direction of propagation, when the vibration is perpendicular direction of propagation, it is transfer wave. What longitudinal wave? When the vibration of the particles are parallel. So when the vibration of the particles are parallel to the which one direction of propagation, it is a longitudinal wave. When the propagation is perpendicular to the direction of propagation, vibration is perpendicular to the direction of propagation, it is transfer wave. Means vibrations are perpendicular, your vibrations are parallel. That is a longitudinal wave. So your progressive wave may be of transverse waves or longitudinal waves. Okay, but all transverse waves and longitudinal waves are not progressive waves. I already explained that one. Okay. What is second one? Second one is stationary waves or standing waves. Stationary waves or standing waves. So progressive and traveling means the waves are progressing, but here stationary means they are not moving, they are standing, they are stationary. That is the meaning of a wave. So wave is stationary, wave is standing. That is that. So another name is standing here. So what is the definition of this one is superimposing of two waves. Superimposing of two waves. Superimposing of two waves is known as stationary waves. So what is superimposing means? Combining the two waves. Superimposing means keeping one wave in the other wave. Superimposing means keeping one wave on the other wave. That is known as superimposing. So when you keep one wave with other wave, then you will get a wave which is known as stationary waves. So to get this superimposing condition, the main condition is to get this wave superimposing condition to get this stationary wave. The main condition is end should be fixed. End is fixed. This is the assumption. Then only we will get this which one stationary wave. Here I will show here. The figure I will show. When the end is fixed, how you are getting a wave. So this is the wave. This is the displacement y. This is time t. So you are getting a wave like this. So what is this wave? This wave is known as transverse wave because the vibration of particles are in the direction of propagation, perpendicular to the direction of propagation. It is a transverse wave. So already you know the definition, transverse wave. Is it progressive wave? No, because distance are different here. You can take same which one? If you take same distance, this one, then you can say it is a progressive wave also, right? Just I took a figure, right? So, but here what is we are discussing on which one, stationary wave or standing wave. So we have to impose one more wave. How to get a one more wave here? If you keep a fixed end here like this end is fixed. Means the wave is not progressing. That's why the name is standing or stationary. Standing wave or stationary wave. You are telling the wave that the wave should stand. So wave is moving freely like this. The transverse wave is moving freely like this, and you are telling by keeping this end fixed, you are telling that to stop here. To stop here means you are asking the wave to stand here. That was standing wave. Or stationary means you are asking the wave not to move further. Means that is stationary means you are stopping the wave to move further. So when the wave stopped here, what the wave will do? The wave will move like this in the backward direction like this. So this one, the wave will move like this. The wave will move like this. Right? So when the wave is moving freely, you are stopping the wave by keeping the fixed end. So to get the which one, stationary wave, the assumption is we have to keep a fixed end here. So when the wave is moving freely, you are keeping a fixed end. So you are not allowing the wave to move further. So what the wave will do? The wave will move in the backward direction like this. Means what happened here? You are superimposing here one wave with another wave. This is superimposing. Keeping this is one form of the wave. This is backward direction. You are superimposing this one. So this type of wave is known as standing wave or stationary wave. Right? Now again, your stationary wave, when you take this one, these particles are vibrating. So this is a transverse wave. Right? When the amplitude is same, it is a progressive wave. Right? So again your standing waves again of two forms, it may be transverse waves if the amplitude, not amplitude, the vibration of the particles are which one perpendicular to the direction of propagation, it is the one form, that is transverse wave. So when they are parallel, it is a longitudinal wave. It is again two types here. Your standing or stationary waves again of two forms. One is transverse waves or longitudinal waves, right? So all transverse waves and longitudinal waves are not standing waves, but all standing waves are transverse waves or longitudinal waves, right? So this is regarding the types of waves. Okay, thank you.